下一位演讲的讲者非常特别哦，他只是一位高3的学生，然后他在奥义科技实习了1年，下一位讲者蔡佳颖，他现在是台北北一女的那个是 AI Club 对不对 ？AI Club 的主席，然后他在奥义科技实习了1年，他今天要分享的他在1年当中把 AI 应用在cybersecurity analyst 上面的一些经验。那请我们大家以最热烈的掌声来欢迎。谢谢。
Good afternoon, everyone. Thank you so much for coming. I'll be sharing this talk in English. So I am Chia-En Tsai, or you can just call me Jacqueline. And in today's talk, I'll be sharing my high school intern project, which is constructing an AI helper for cyber threat intelligence analysis. And during the talk, I will introduce several common and useful NLP tools, and also share my perspectives as a high school intern. So first, I would like to give a brief self-introduction. I'm currently a rising senior in Taipei First Girls High School, which just means I'm about to start my last year in high school. And at school, I'm also the Artificial Intelligence Club President, and I've also been an intern in CyCraft, which is 奥义智慧科技. And basically, we're just a cybersecurity startup, and I've been interning there for 1 year. So before talking about my intern project, I would like to first share my perspectives and reflections as a high school intern, which hopefully can encourage more high school and college students to participate in interns. So first is actively reaching out. And the reason I wish to give this advice to students traces back to the time when I started my high school intern journey. So during last year's summer, I had the opportunity to bring my AI club to CyCraft and to have a tech company visit. And the picture on the top left corner is the picture we took during our visit. And during the visit process, I observed there were other interns participating in a cybersecurity competition called Capture the Flag. And at the time, I thought that was so cool for me because I've never actually exposed myself to cybersecurity ever before. So then I told them that I really wanted to have an intern opportunity. And after giving a resume and having some interviews, I was very fortunate to be interning here for 1 year. So I hope this kind of example can encourage more high school or college students here to actively pursue their dreams in technology or programming. And the next one I would like to talk about is knowing what you want. Because during my intern, I was often asked by my peers and teachers, they would ask me how do you really manage schoolwork, your clubs, and intern, all these activities at the same time? And at first, I just gave those old replies, self-discipline and determination is what made me manage so many things at the same time. But the more I thought about it, I realized that these answers all trace back to one sentence, which is just knowing your goals. An actual example I had is that there was a time when I had to decide between intern and the programming training in our school. And I knew that at the time, instead of just practicing common coding competition problems, what I really want is practical machine learning implementation. And also, I wanted to have an actual NLP project where I can demonstrate to a lot of people. So in the end, I decided to continue my intern during the year. And I think during the process, my ability has significantly increased. And also, I've learned a lot of cybersecurity knowledge along the way. So I would like to encourage more high school and college students, if you're hesitating between what should I do? Should I do some research or should I do any kind of project? Maybe you can try to first think about what do you really want to achieve during your high school or college years. And the two use and implement and problem finding and solving are the two kind of gains that I think that I achieved most, aside for all the machine learning and NLP technology that I got from my intern. So first is use and implement. So during the use and implement is one of the things that I think I learned most during my intern years, because for us high school students who want to learn more about AI or machine learning, whether we try to learn it from school or from other sites, online sites, we could only get only abstract concepts, but there was no actual implementation. It was not until during my intern that I was able to actually construct an NLP project and actually implement all the NLP tools I've learned. And I think this really helped me a lot during the process. And the other one is problem finding and solving. And problem finding is not just like in common coding competitions, like just finding the bugs in code, but also trying to like consistently optimize your code. And I think the intern year has really helped me a lot in elevating my abilities. And the other problem solving, I will talk more about it when I'm introducing my project. And this is another activity I participated during my intern. It is called the IT Home Cybersecurity Exhibition, which is last month in August. And this is the first time I participated in an exhibition, not as a visitor or not as a visitor, but actually I was there at the booth, at our cybersecurity booth, and actually introducing to the visitors about cybersecurity knowledge and teaching them how to play our cybersecurity game. And this is the picture that we took together of all of the interns, and this is me at the booth, like trying to teach like a lot of visitors about the cybersecurity knowledge. And I think this kind of experience is really hard for me to get if I just only participated in a research or in any kind of competition. This is something I really want to share to all students. Okay, now I'll go straight into our project goal. And for our AI helper and cyber threat intelligence analysis, there are 3 main project goals. Now I'll talk about the first one, which is classifying articles from the largest Chinese security website. So our purpose for this project goal is that we wish to help the security team to quickly identify the articles related to their daily missions. So our data source for this project goal is Freebook. And I don't know if anyone has heard about Freebook before, but Freebook is actually the most prestigious cybersecurity website in the Asia region. And it has a lot of rich and up-to-date, simplified Chinese cybersecurity articles and information. And due to time constraints, so I only picked like 2 of the most prevalent cybersecurity topics for this project, which is vulnerabilities, 漏洞, and also enterprise security, 体验. And for vulnerabilities articles, it's more about like the actual, how like businesses actually discover the vulnerabilities and how they actually use actual implementation details to actually detect these vulnerabilities. As for enterprise security articles, it's mostly about like introducing like what kind of threats are there to different enterprises and how enterprises tackle the problems. So there are mainly 4 small procedures for our first goal, which is determining whether a cybersecurity article actually belongs to vulnerabilities category or the enterprise security category. So the first step in our first goal is for data crawling. So since during my intern process, I really wanted an opportunity where I can start my learning from the basic data crawling. So for this process, I actually constructed my own Python crawler. And in order to construct my own Python crawler, I actually consulted the Freebook source code, which is shown at the left side over there. And I tried to look for a pattern to help me decide how to retrieve the links for each cybersecurity article. So I found the pattern and I collected the article links together, and I started extracting each news article through each article link. And this process, although it seems very easy to understand, but it's actually very difficult for me. For the first thing is that it's because the Freebook source code is really, really complicated. The source code I demonstrated on the left is actually after a lot of simplifications of the source code. The Freebook source code is actually very complicated. So it was very hard for me to find the pattern of each article link and try to write a Python rule to actually extract these article links. So this was one difficult thing about my crawling process, and the other difficulty I encountered is that after I crawled the website too often, I was often denied access into Freebook because they may think I'm kind of like a hacker or something into their website. So I have to be denied access for a lot of times, so I have to wait very long, and the process is very time consuming. So after getting all the text from the FreeBook website, the next step would be data processing, because the original data may have a lot of unimportant information, so I have to sort of filter it. So there are mainly two stages in my data processing. The first one is tokenizing. Tokenizing just means that I put a large article as an input, and I cut them to meaningful words and phrases. So my NLP model can use these words and phrases as a specific keywords to determine the classification. And the other stage I have is removing stop words. And stop words are basically words that are very common in general, they are so meaningless that they interfere with the classification results. For example, common conjunctions like 可是因为而且 those kinds of conjunctions that don't really help us in classifying the articles. So the tool I used for tokenizing is the Java Chinese tokenizing library, because as I mentioned, the FreeBook is full of simplified Chinese cybersecurity articles. And Java is a really good tool for for tokenizing simplified Chinese articles. And as for the stop words, I used a simplified Chinese stop word list from a Chinese university. And not only this, it has a lot of conjunctions, but I also included some common technical terms in the cybersecurity articles, because since we're dealing with classifications for cybersecurity articles, I must include some of these common technical terms because they also don't really help with the classification as well. Some common terms are 代码、项目信息. These terms often occur in a lot of cybersecurity articles, but they don't really help us in understanding the classification. So then we'll move on to the data pipeline. And our data pipeline is consisted of mainly 3 NLP models. The first one is called count vectorizer. And the basic function of count vectorizer is that it converts a text document into a matrix of word counts. So in the example below, for example, if I have 3 really wordy articles, and I really want to convert it into this kind of matrix where it shows how often each term occurred in each article. So what count vectorizer does is that it converts this wordy article into this matrix that helps the NLP models understand better. So the purpose I used count vectorizer as my first NLP model is that I wish to use this count vectorizer result as the input data of the TF idea, which is the next NLP model I will introduce. Okay, so our next NLP model is TF idea. And its function is that it evaluates an importance of a word to a file in the file set. So the actual calculation of TF idea is shown over here at the bottom right corner, but its basic principle is that the word importance increases the more it appears in the file, but the word importance decreases if the word exists in many files. Because if a word exists in a lot of files, then usually it means that this kind of word is really general and common, and it doesn't really help us in understanding what kind of type the article belongs to. So that's why we have to sort of degrade the word importance if it's very general or common. And the purpose we use TF idea is because we wanted to let the Beta classification model identify the important word tokens and use them as a classification basis, rather than using the common and general words that don't really help us a lot. So I would like to give a really simple example to show how TF idea actually determines the word importance. So for example, I have 2 documents. The first document says the sky's blue, and the second document says the sky's not blue. And since both articles contain the sky is blue, then the word not is especially important in helping us determine which article the words belong to. So in the TF idea calculation, TF representing term frequency and idea representing inverse document frequency, we can tell that the word not, actually the word importance here is much larger than all of the other words. because it's relatively important for us to determine which type the article belongs to. So I'd like to also share about the advantages and drawbacks of the TF-IDF transformer. Like I mentioned, the TF-IDF transformer is very simple implementation, and it is also very easy to understand. Moreover, it can also help us filter out some common and irrelevant words during the process. However, its drawbacks is also a very crucial disadvantage of this transformer, TF-IDF transformer, is that TF-IDF cannot actually reflect the position information of the word. What does it mean by that? It means that, for example, if I have a word that appears in a Word document title, or if it appears in the beginning or at the end of the article, then usually it means that it should be more important, right? But however, TF-IDF cannot capture the word's position in evaluating the word's importance. And last most important NLP model I use for the data pipeline is called the SGD classifier. And it is the main NLP model I use to help me determine whether this article belongs to vulnerabilities or whether it belongs to enterprise security. So the function of stochastic gradient descent is that it linearly divides many different types of data into different categories, as shown as this example visualized demonstration on the right here. So each data point would represent a single article, and what SGD does is that it tries to find these kind of boundaries and to tell which classification this article belongs to. And the purpose, of course, for this stochastic gradient descent is to help us classify between vulnerabilities and enterprise security. And its feature is that it only picks one sample for each step in determining classification boundary, so it's very efficient. And I'd like to give an easy example to show how stochastic gradient descent is much more efficient than a traditional gradient descent. So let's just assume, make it a simple example, is that we're trying to find the line of regression between weight and height. So we have a weight as an input, and we're trying to get a predicted height as our output, which means that we actually have to know the slope and intercept for our line of regression. So stochastic gradient descent would randomly pick one sample for each step and use it to calculate the derivatives for intercept and for slope. However, in traditional gradient descent, we will have to plug in all of the data points for just these three data and calculate 3 times for each intercept and each slope. So it will be very time consuming. And in comparison, SGD classifier would be much more efficient in determining the line of boundaries during the classification process. So the advantages of SGD classifier is that, of course, it's very efficient and computationally fast. However, its drawbacks is that it's very computationally expensive, because every time I have to determine the classification boundaries, I would have to use all of my computer's resources to process only one single training sample at a time. So it's very computationally expensive. And the last part is evaluation. After so many introduction about NLP model, it's time to have a sort of visualized demonstration of my actual results. So a matrix for the precision of vulnerabilities is enterprise security. The precision I had for vulnerabilities articles is around 92%, and the precision I have for enterprise security articles is around 95%. Of course, numbers are really abstract to understand, so I actually provided 4 examples of the actual classifications I constructed. So the first example is the second testing data. And this is an example of a correct classification I got after processing the model in my Jupyter notebook. So in this article, its actual category in FreeBuff is vulnerabilities. And the model has successfully predicted that this article is a vulnerabilities article as well. So there is not much problem with this article. However, for this 10th testing data, there were some problems that we got because it is a wrong classification. In Freebook, this article actually belongs to vulnerabilities. However, what I predicted is that this article is actually from enterprise security. And so I decided to look more in depth into this article, and I found that although this article mainly really talks about vulnerabilities, but there's a crucial word that appears very often in this article, and it's called MageCard. So MageCard is actually a hacker group that tries to hack a lot of personal information in financial corporations. And maybe it was because that it detected the word MageCard that made it think that this may belong to the enterprise security. And the other really interesting example is that although Freebook put this into the vulnerabilities category, but actually what I predicted is enterprise security. And this article, although it talks a lot about vulnerabilities and how the Stuxnet worms actually try to attack these vulnerabilities, but actually it's more of an introduction about how this Stuxnet worm actually intrudes enterprise security. So we think that actually, after consulting with a lot of cybersecurity professionals, we think that this article is more likely to belong in enterprise security rather than vulnerabilities. And due to time constraints, I'll skip the last example and move on to our second project goal, which is setting up the recommendation system of prevalent cyber topics. So for this project goal, what I want to do is I want to pick top 10 cybersecurity topics, respectively for vulnerabilities and enterprise security articles. So what I use is single value decomposition, which is SVD for short. And its function is that it decomposes a complex count vectorizer matrix and decomposes it to more small matrices. The reason I wanted to use SVD as my recommendation system comes from the inspiration from a Japanese research, which is animal clustering using SVD. So what this Japanese research does is that it collects a lot of animal-related articles and put them into the count vectorizer. And it uses the matrix that count vectorizer gained and put it into the SVD model. And what the Japanese research discovered from this SVD model is that from the subject vector, it contains a lot of matrix of different clusters based on inter-item similarities. For example, they found out that dog and cat are put together as a cluster, as a pet cluster. And the lion and tiger are put together as a wild and carnivorous cluster. And the bottom left corner is a visualized demonstration of how SVD helps cluster the different inter-items. So after the Japanese example, I was thinking that what if we actually put our previous count vectorizer results into this SVD model? Will we be able to get many clusters of different cybersecurity tokens as well? So I put a lot of my vulnerabilities article count vectorizer results into this SVD model and looked at the subject vector. And what we get is that PHP and JWT occurred very often in the top 10 vulnerabilities topics. And JWT is basically a user authentication method. And the reason that it appeared so often in the vulnerabilities topic is because that recently there are a lot of cyber criminals that found out this kind of authentication method actually contained a lot of flaws for them to attack. And PHP is just a common website programming code and because it's so popular that a lot of cybersecurity professionals actually discuss a lot of this programming language. And it's the reason why it also appears so often in vulnerabilities. And the next one is the clusters of enterprise security articles. So basically, I did the same thing with the enterprise security category, and I observed that financial corporations, mails, and CVE, these three tokens, appear the most in enterprise security topics as well. And since financial corporations and mails are very common in enterprise security, I would like to talk about CVE. And CVE is basically a vulnerabilities data set, and a lot of enterprises refer to this when they're being attacked by a lot of cyber criminals. And that's why it appears so much in enterprise security topics as well. And lastly, I'll move on to my last project goal, which is recognizing attack techniques in articles and labeling them with MITRE attack techniques. So MITRE attack is basically a framework of adversarial tactics and techniques and procedures used by cyber criminals. And what the MITRE attack framework is so special is that it maps and indexes virtually everything regarding an intrusion from both the attack and defense sides. In our data source, because we're dealing with Chinese NLP analysis, we use FullHub, which is basically a translation of MITRE attack into simplified Chinese. And for detection, we selected 26 most frequent and important attack methods. That includes the attack methods from all of these procedures. So this is a basic layout for how I try to use MITRE attack use MITRE attack techniques to detect attack descriptions in articles. The first is data crawling and processing, and since I've talked about this previously, I'd like to focus more on the labeling data. So for our data, we use sentences from each MITRE attack description. And as for our labels, we use sequential indexes as the MITRE attack labels. And one thing that's very special about this is that we use non-attack descriptions. We use a specific tag for non-attack descriptions. The reason we did this is that because during my process, I actually encountered a lot of generic statements. For example, some of the MITRE attack descriptions would just tell me that, oh, you should really pay attention to this kind of attack method. And these kind of sentences don't really actually refer to a specific MITRE attack method, and it actually interfered a lot with my detecting procedure. So I decided for these really generic statements, I would assign them a specific tag so my model would know not to look at these non-attack descriptions during my process. So basically I used 3 of the classifiers I learned during my intern process and put them into my MITRE attack detection model. So first I used SGD, and since I previously introduced it, I'll immediately move on to naive Bayes, which is the second classifier I used. So this is the data pipeline I used for the naive Bayes classifier. And naive Bayes is basically another kind of classifier that depends a lot about the token probabilities. So I used a more simple example, which is filtering spam mails as this example. So let's assume that we have a training data of normal and spam emails, and the frequency for normal emails is around 2/3, and for spam emails is around 1/3. And also the frequency of each word token in each kind of email is also distributed on the left. And what naive Bayes does is that if today I have an email that says free reminder, and naive Bayes calculates the normal message score and spam message score to determine whether this article belongs to a normal email or a spam email. So for calculating the score, it just multiplies how often a type of email appears in the training data, and also multiplies how the probability of each word that appears in a normal email in order to calculate the normal message score. And the same idea goes for the spam message score as well. And through this example, we can tell that spam message score is much higher than the normal message score. So naive Bayes would tell me then that this email is most likely to belong in the spam email. And however, naive Bayes has a really significant drawback, is that called the zero conditional probability problem. Because for features that have 0 frequency, the total spam message score would result in 0. For example, today in my training data, the word lunch never appeared in a spam message before. Then if today I have a email that's called free lunch reminder, then my spam message score would be 0 because of that 0 probability. And as a result, although intuitively we can tell that this email actually belongs to the spam message, naive Bayes would instead tell me that this email actually belongs to the normal message instead. So this is a really significant problem that I faced a lot during my project, because a lot of the words I had in my testing data articles didn't really appear in my training data. So it resulted in that my precision for a naive Bayes is actually the lowest of all the 3 classifiers. And the last classifier we use is decision tree. And this is the overall data pipeline of decision tree, consisting count vectorizer, TF idea, and the decision tree classifier. So the decision tree classifier is very easy to understand because it just uses the input data, and as it asks the input data a lot of yes/no questions or conditional statements determine whether the input data belongs to which category. So for example, if a doctor is trying to give a patient advice and uses the input data, it will first determine whether the patient is older than 40 years old, and then it will determine its resting heart rate, and it will determine how often this patient eats donuts. And through the decision tree process, we can tell that this patient needs to go easy on the donuts and get some exercise. And these green boxes actually represent the classification, MITRE ATT&CK classification results in our project. So basically, the advantage for a decision tree classifier is that it is very easy to understand and it's very versatile because you can use decision tree to solve a lot of business problems. However, its drawback is that it is very unstable and it requires a higher time to train the model. So moving on to our evaluation, precision for each kind of classifier is demonstrated here, and we can tell that of all 3 classifiers, stochastic gradient descent actually performed best, which has an accuracy of 43.6%. And although 43.6% actually requires a lot of improvement, but it's much better than the result of randomly guessing between the 26 MITRE ATT&CK methods, which is only 3%. So actually, after the evaluation, I decided to put some of my free book articles I previously crawled and put them into my SGD model to see how the results were turned out. Actually, I prepared a video in case something went wrong to the internet, but actually what I did is that I used Flask to create this website, and I put an article from FreeBuff into this model. The FreeBuff article I used is related to APT attacks. And what I did is that I just put them into this model, and after I submit it, it will appear a lot of the MITRE descriptions it detected from this article. So basically, this is the MITRE attack description detection that this SGD classifier actually detected. And for each detection it detected, is that there will be a sentence that says, the model says, oh, maybe this sentence actually belongs to a MITRE attack. And it will predict the most likely type of MITRE attack this sentence belongs to. And it will also show the top 3 attack descriptions and the top 3 attack probabilities for this sentence. And I'll move on to a more accurate example is that in this article it talks about FTP upload PHP, and it predicted it as a type for T1100. And since this is a MITRE attack framework, T1100 actually refers to the web shell attack. So after determining that this sentence is a web shell attack, it also listed the top 3 attacks it thinks that this description belongs to, and also the top 3 attack probabilities. in the end, a short conclusion for this is that for all three of my project goals, I only used very common and simple NLP models, and I was able to achieve a accuracy and precision that's much higher than the random guess procedure. And I would also like to really thank my intern mentors during the process for guiding me through the entire project. And thank you so much, and it's now the Q&A section, and if there are any questions in English or in Chinese, I'll be happy to answer them.
谢谢嘉颖给我们那么精彩的演讲，对，但是因为已经超15分钟了，所以if you have any questions, you can ask Jiayin in private. Thank you. Let's thank her again.